Hey guys, how's it going? This is Siri and I'm back with another PyTorch video for you guys. And today we're going to be talking about named tensors. And so named tensors are in its experimental phase right now, so we'll see how prevalent they get. But it is an option for us if we find our tensors to be too crazy and if our dimensions are like super duper high and we have like no idea what's going on, then I think named tensors might be a good thing to check out. So our tensors are usually filled with data, right, that represent different things within their different arrays. So we have an outer, by the way, tensors are just multidimensional arrays, right? So you have an outer tensor and you have an outer array, and you have multiple different arrays in the outer array, which represent different facets of our overall data. So for example, if we have an image, we have three different characteristics to that image, and so if we have like a 2D image, we have the color channels, which just tell you the RGB values, so the red, green, and blue. And so like for each pixel that we have in our image, we're going to be having three different values associated with it. So that's one piece of that's one type of information that we have in our image. The other two are the regular height and width, and so we would have two different arrays for that. So we have three different arrays in our overall, like our outer array. And so like images might be like sort of manageable, I guess, but like if you start to, have more dimensions that aren't just your color channel. So for example, our image was 2D plus our color channel, so its overall it had 3 dimensions. But if you had like some data that was like volumetric data or like CT scans or something like that have higher dimensions, then things might get like hectic, right? So you'll start to forget which array represent which type of data, and so you'll start to get confused. And so if you want to print out some part of your data and you don't know like where it is and what you're printing out, if you just get a random string of numbers, it's going to be chaotic and it's not going to be fun. So what PyTorch has to offer, although it's in its experimental phase, is named tensors. So what you can do here is that you can name the different arrays within the overall outer array. So you have different names representing which types of different data that you have. So whether it's color channels, the length, or the height, the height or the width. So yeah, as the dimensions grow larger, it can be difficult to remember which tensor represent which data. And so, for example, if we have an image, okay, and let's set it equal to a random tensor, but what we do know is that it has 3 color channels, so that's going to be 1 dimension, and you have the rows and columns, which is just like the height and the width. Yeah, so 5 and 5. Okay, so this is just the shape of the image. So you have the color channels, rows, and columns. So the rows is just going to go from up to down, so that's going to be your height, and then your width is just going to be the other one. Okay, so let's figure out some weights that we can use for our image. So maybe we can have, torch.tensor and like whatever. Like I'm just making up numbers here, so and maybe, oh. Okay, so those are your weights, and your batch is just how many samples of images you're going to be passing in to like a network at once. And so maybe our batch can be torch.rand n. So we're going to have two batches. So the batches is most often like the first dimension that you specify when you're passing something in. So let's say that there are two batches. There are 3 color channels and the dimensions of the actual image. Okay? So this is the shape of what we're passing in. We're not actually going to be passing anything in, but just to give you an example. And the main topic of this video is name tensors, right? So let's, let's name these tensors. So what we can do is we can take in a parameter name. So for example, if we have weights, right, which are just our tensor that we're like the values that we're multiplying the input by, if we set the names equal to like, I don't know, the different channels. Actually scratch that. Let's set some, so these are all factory methods, like methods that we can use to initialize and create tensors. So that's what we call these different methods. So we can set some names. So we can say names is equal to like a tuple that represents what we want. And so let's just say channels and like height and width. So if you run this, okay, wait. Okay, so name tensors are just an experimental feature, like I said. They're subject to change, okay? And so what they're saying here is please don't use them for anything important until they're released as stable, okay? So if we print out image now, we see like the different, the different values, the different random values. And yeah, and then the names are going to be channels, height, and width. Okay, so you can use it for other factory methods as well. You can, so some examples are like torch.empty, torch.rand, torch.ones, torch.tensor, just to create the tensor, torch.zeros. And so what we just did here is we named our dimensions. And an interesting thing to also pay attention to is that if you want to, if you want to add names to your tensor, but you don't want to modify the existing ones, then you can use another function called, or like a method called refine names. And this is used if you want to add names but don't want to modify the existing ones. And so what you'll do here is that you'll do like a ... to represent the previous dimensions, and then you would, you would add the ones that you want to add. So an example of refined names would be like if you had a tensor that was again filled with random values, like torch.rand and maybe like 2, 3, 6, 8, and 10, or maybe 2, 4, 6, 8, 10. That makes more sense. Okay, so let's make this code cell. So the default ones aren't going to have names, right? So if you want to change that and modify that, you want to add names, but you don't want to modify the existing ones. And the existing ones are by default none, so they don't have any names. And so since the default is none, if you want to add names but don't want to modify the existing default none names, then what you can do is, like I said, you can add ellipses and like a dot dot dot, and say that tensor is equal to tensor dot refine names. So what we're doing here is we are we're modifying tensor and setting it equal to itself, and so what we can pass in are the names that we want to modify. So A, let's say that A will correspond to 2, like this first dimension that has like 2, and maybe the other ones I don't want to modify, so let's keep them as default. And like maybe like 8 and 10 can be B and C. Okay, and if we want to print out tensor.names, then what we get is A. Okay, so for the default is okay, wait, let's change the names. Let's just make this tensor1. Okay, and let's print tensor1.shape before we refine it, and let's print it after. Oh, okay. Print tensor1 actually you don't need a print for the last line, but okay, so see here, this is none, 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 none. Those are the default, so those are the existing ones, like I said. And now A, okay, and then none, none. We don't modify any of the stuff that is represented by the dot dot dot, and then the B and the C go to the 8 and the 10. Okay, so that's for fine names. There's another one called rename. And so, like if we have, this is like changing them all together. So if you want to modify and or, overwrite /drop, then you would use rename. So you can use it to drop the dimensions altogether by saying like a tensor dot rename, and then pass in none, and then it'll get rid of all the names and it'll go back to the unnamed tensors. So now you can, so an interesting thing is that you have named tensors and you have unnamed tensors, and so there are different functions that you can use. Actually, there are more functions that you can use for unnamed tensors, so that's probably something you want to look into, because like named tensors only have like a limited scope of factory functions that you can use on them. And another interesting point is that you can have like what we see here, like you can have some of the dimensions be named and some of them be unnamed. So, but you would still consider this a named tensor because we have names for them. But yeah, you can have more access to different factory functions that are pretty common and that you probably want to use if you have an unnamed tensor. So yeah, that's what I mean by like experimental phase. Like not everything's available to them. So yeah, and they're subject to change. Okay. So yeah, that's rename. And you can probably use it for the same purpose if you want to modify them, but rename has an additional functionality in that you can actually drop certain dimensions if you wanted to. So that's the main difference. Yeah, so yeah, I think that's it for actually maybe there's one more thing. The method align as, yeah, there's another method that we could talk about, which is align as. Okay, and so what this is useful for is that if we have, two tensors that we are operating on, we can, change up the order of the dimensions using the function .permute. So it can change the order. And this is also useful if you want to do some visualization. And so, like if matplotlib requires you to pass in the tensor with like the same dimensions except like just shuffled around, then you can use this function to help you. So yeah, what align as does is that it returns a tensor with the missing dimensions added and the existing ones in the right order, so using like the .permute. And okay, yeah, so that's basically it. Okay, so now we're done. So I mean, like if you wanted to, it would be a cool thing to experiment with. But like we said here, don't use them for anything like super important until their release is stable. But yeah, this is probably like a good overview of what named tensors do and what they're used for. So yeah, I hope you learned something new today, and I'll look forward to seeing you in my next video. Thank you so much.